Oh, right. So, drawing a Lewis structure for a molecule with one central atom and no octet rule exceptions. We'll get to that in a bit. Okay, so following our procedure, then we have the carbon dioxide molecule. So, the first thing is we have to top up all our valence electrons. So, we've got one carbon, okay? So, that is 1 times 4 valence electrons because it is sitting over there in group 14. And for oxygen, we got 2 oxygen atoms in there. So there's 2 lots of 6 valence electrons. So that is going to be a total of, drum roll please, 16 valence electrons, if I can add, hopefully. Okay. All right. So that is what we're aiming for. What is the central atom going to be? Well, carbon has got 4 valence electrons, so it's got a bonding capacity of 4, wants to form up to 4 bonds. Oxygen has got 6 valence electrons, so it's got a bonding capacity of 2, wants to form up to 2 bonds. So carbon is going to be our central atom. So we're just going to join oxygen to carbon to oxygen, just keep it nice and symmetrical, and we're going to join them up with single bonds, and then we are going to complete the octets on our peripheral atoms, which today is oxygen. So let's give each oxygen an octet, and then we'll have a little tot up and see how many valence electrons we have got in our structure. Sorry, these aren't pretty. I haven't found a better way of doing this. There probably is a better way of doing this. Anyway, so how many valence electrons have we got? We've got 2, 4, 6 lone pairs on each oxygen. So 8, 10, 12. And then our bonding pairs take us to 14, 16. So we've got all our valence electrons. Very good. The trouble is, carbon does not have an octet, does it? It's not very happy because it's only got 4 electrons around it. 2, 4 from those 2 bonding pairs. So that is sad face for carbon. Okay. So what we're going to have to do is we are going to need to take some lone pairs of electrons and convert them to bonding pairs of electrons. So let's do this in a symmetrical fashion. So we'll take 1 lone pair from each oxygen because carbon's got to get from 4 to 8, so it's going to need an extra 2 pairs of bonding electrons. So what would that then look like? So these guys would go from here to here and from here to here. Sorry, it's kind of messy. So then let's redraw. So we got oxygen, we got carbon, we got oxygen, and now we're going to join them up with double bonds like so. So carbon should have its octet, and after we have moved those bonding pairs of electrons from each oxygen, it's only going to have, sorry, the lone pairs of oxygens, it's only going to have 2 lone pairs per oxygen. So we'll have something a little bit like this. So let's just check that everything looks good. 2, 4, 6, 8. Who do we appreciate? Carbon with a happy octet. 10, 12, 14, 16. So we haven't stuffed up our number of valence electrons. We've still got 16 valence electrons. And carbon should now have its octet. Yes, it does. Okay, because it's got 4 pairs of bonding electrons around